क्या वैसे सर को देर हो रही क्या? हैं? अनम्यूट योरसेल्फ.
नो सर, ही इज कमिंग, जस्ट कमिंग। एक्चुअली रजिस्टर करके फिर उनको प्रोसेस में थोड़ा सा वो हो रहा था, कोई दिक्कत नहीं। देखते हैं, कॉल कर रहे हैं।
Malik, have you passed the message to Nidhi?
Hello.
Hello, sir. Have you?
Hello.
Ajay sir, can you listen?
Answer, sir. Are you audible?
See in the participant is
Yes.
yes, he is there. He has joined. He has joined.
Yes,
Yes,
sir.
sir.
Hmm.
Answer, sir, are we audible?
Connecting to audio.
Ah,
Namaskar,
Namaskar,
sir.
sir.
Yeah.
Sir, good afternoon.
Namaskar, sir.
Good afternoon, sir. Good afternoon.
Answer, sir, you are mute. You are on mute, sir. Please unmute yourself.
Yes, sorry. Now I think it's okay.
Yes,
Yes,
sir.
sir.
It's
Yes,
okay. And welcome.
Yeah, please.
Yeah, Malik, you can start now.
Yes. So, I welcome everyone in this technical session 5 on the last and final day of our international workshop on technological advancement in renewable energy. We have as our guest and invited speaker, Professor Achal Srivastava with us. This session will be chaired by Professor Dr. Kuldeep Dwivedi. He is the HOD EVS and also the convener of IWTL, this workshop, and also as the Deputy Dean Academics in Amity University, Madhya Pradesh. We have our co-chairman, Dr. Abhishek Bharadwaj, is assistant professor in this Department of Environmental Science, and myself, Dr. Ritabrata Malik. In the beginning, I would request Chairman Sir, Professor Dwivedi, to address the session with his few words.
Good afternoon to all, and a warm welcome to Professor Achal Srivastava ji. Sir, welcome from our side, and that you have accepted our invitation to deliver a lecture. And the participants and the faculty members present over here will be highly benefited by your expertise and your vast experience and knowledge. So now I hand over the proceedings to Abhishek so that he can invite our esteemed guest for his lecture.
Thank you, sir. So, uh, thank you very much, sir, for address to Answer, sir. So, sir, most welcome. Yeah. So, I transfer to the things to the Dr. Malik, sir, to read your CV.
Yes, thank you, Dr. Abhishek. It is my honor and privilege to introduce Dr. Achal Srivastava. He is presently working as a professor, Department of Physics, Institute of Science, Banana University. He has received Vice Chancellor's Award for Excellence in Research, BHU, in 2014, as a Max Planck India Fellow from 2008 to 2011, and jointly given by the Max Planck Society, Germany, and DST India. Boycast Fellow from 2008 by DST India, Young Investigator Award, 7th World Congress on Nanobio 2013 in South Korea, DST Award for Meeting of Nobel Laureates and Students in Lidau, Germany in 2005. Dr. Anchal was the Visiting Research Fellow to MRC RPI, Troy, New York, USA in 2006. His research area is structural and spectroscopic studies of inorganic quantum dots, carbon nanotubes and nanorods, and two-dimensional graphene TMDs and nanoribbons. Dr. Anchal has published more than 145 research articles, 4 book chapters, and 6 review articles. He has filed 5 patents, out of which 2 has been granted. Dr. Anchal has several international collaboration in his research domain. I hereby welcome Professor Srivastava to address the session. Sir, you can start.
Thank you, everyone, and thank you for inviting me in this international workshop on technology development and advancement. I want to discuss today something which is regarding device thing and how you characterize your device, and for that which technique is there, which is very relevant to make the device, because all devices are their single crystals or polycrystalline materials, and to really see their defects, because in solar cell, for example, there is impurities play a very important role. So how much impurities is there, how you can really figure out those impurities, how you can see those impurities. For that, you have to have a facility which is capable of seeing atoms. And today, I am going to talk one technique which is now well known for their um, their capability of seeing the atoms or very small quantum materials. And for that, a technique which is known as transmission electron microscope. So today I will discuss the basic fundamentals of transmission electron microscope, which is very important if you do any kind of research. Those who are working in energy or any other aspect of science, you need to look into the material at the level of atoms or couple of atoms, and for that you have to have a facility available with you to understand their structure, their morphology, their lattice parameter, their chemistry, their spectroscopy details. So this all can be done by one technique which is known as high resolution transmission electron microscopy. So for that, I am trying to try to share my screen, and let me share my screen. Give me some second. I just want to share my screen.
Okay, sir.
Hmm. Documents are there. Selection in image or PDF. PPT ये ले नहीं रहा है, ऐसा क्यों?
लेगा सर, शेयर करने पे लेगा।
शेयर स्क्रीन कर दीजिए।
Share screen.
शेयर स्क्रीन
There is a green, there is a green button. Share green.
सर स्क्रीन शेयर करने के बाद उस जगह को क्लिक करना पड़ेगा जिसको आप शेयर करना चाहते हैं, उस पर बटन से एक बार क्लिक करना पड़ेगा।
स्क्रीन शेयर तो हुई लगता है। अब कहाँ स्क्रीन शेयर हुई?
हाँ सर, स्क्रीन शेयर हो गया।
अच्छा, ओके। तो अब तो दिख रहा होगा शायद।
करेक्ट सर, पीपीटी दिख रहा है, बस उसको फुल स्लाइड, हाँ पूरा दिख रहा है सर।
Okay, so I will discuss today the technique which I am talking about, where they have capability to see atoms, and I'll try some application. So as you know, nature has given us a tool to see, and that is our eye. And eye has a resolution of 0.2 millimeter. It means that we cannot see below that 0.2 millimeter with our eye in a best situation. Eye has, nature has given an eye has a lot of quality. For example, it has self-cleaning, self-protecting, made up of cells, and it is connected with your brain. So every good quality is there. So nicely, nature has provided this facility to look. But the only problem is that we cannot see lower, smaller things. So for that, the scientists has developed another tool, which is optical microscope. And optical microscope has, everybody has used it. And the problem with the optical microscope, with all facility they have, uh, 0.2 micrometer, even better microscope is available, but based on some other techniques. But the technique which is required to see atoms or viruses or very, very smaller organs or tissues, which size is of angstrom or nanometer or quantum material or nanomaterials, for that people has developed electron microscope. So the question is that, as you know, let us talk first 10th high school thing, that why a image will form. So image will form. For that forming an image, you need a lens. It is very necessary. Without lens, and then you need a source of light. So you, in visible lens for our eye, we use visible radiation, which is blue to red or white light, and then we form an image, and it is connected, image will be formed on your eye, and it is connected to the brain, and we can visualize it. So this is the one thing is very important, is lens, and the radiation which is used here is visible light. So glass lens and visible light, and in our eye, the lens is made up of cells, transparent cells. So the problem, as I told you, that there is a problem of microscope, sorry, eye, that we cannot resolve better. So the question is how we want, what are the problem we are facing if we want to see smaller and smaller things. And the problem is resolution. And resolution actually given by two scientists, actually one scientist, I can say, Rayleigh criteria. Rayleigh has given this limit of resolution, and it is dependent on wavelength and sine alpha. So the formula is 0.61 lambda by sine alpha. Sine alpha is the aperture angle, and actually 0.61 is a constant, so it is dependent on lambda. Lambda is the wavelength of light. So for best situation, we can use a smaller wavelength for better resolution, and therefore for visible light, we can use blue light or for better resolution. But there is a limitation. You cannot go below blue line because our eye cannot see that. So optical microscope has a resolution of, as I told you, 0.2 micrometer around. So the next question will come in the picture, that we can use visible light, which is electromagnetic radiation. Okay. So electromagnetic, we can make other uh, other microscope based on other electromagnetic radiation whose wavelength has smaller. For example, ultraviolet, X-ray, and gamma ray. Okay, so their wavelength is shorter. So for better resolution, we can use, this is logic says like this. Logic says that since we are using visible light, which is electromagnetic radiation, we can plan microscope based on ultraviolet, X-ray, and gamma ray. But the question is, here I'm asking the question, why electron-based microscope has been developed and not X-ray and gamma ray? As I told you that we need a lens to make an image. Therefore, the answer is that why electron has used and not X-ray and gamma ray is the development of high performance lenses, which is necessary to focus the beam to form an image, which is not exist for X-ray and gamma ray. So if anybody can make lenses which can very precisely make X-ray and gamma ray to focus and to change their direction, then a microscope can be developed using X-ray and gamma ray. The question is that uh, how you can make the lens of electron. This is the question. So you know what lenses does. Lenses change the direction of the light depending on their focal length. Similar thing, if you can change the direction of electron, then you can use it as a focal lens. So how electron direction can be changed? We have studied in 10+2 level that if you apply a magnetic field perpendicular to the direction of electron beam, it will start circulating. It will changing the direction, and therefore, actually using electromagnetic lenses, you can make this uh, electromagnetic lenses or magnetic field. For example, you apply an electric field, produce a magnetic field, and that magnetic field perpendicular to the direction of electron beam, then direction will change. And therefore, people have used this information, and this information that electron can be focused using magnetic coil has given by one scientist in 1927 by Hans Buss. And when Hans Buss has shown that electron can be focused using magnetic coil, now it is in 10+2 level, then it two scientists named as Ernest Ruska and Max Knoll. They are the two scientists who make the first microscope. I'll show the picture of that first microscope made up of this two people, two scientists. This is with a lab coat, which is known as Ruska, and with a black coat, it is his boss, Knoll, Max Knoll, and they make the first microscope. This is the transmission electron microscope, which was developed in Berlin in 1930. So the thing is that how the basic fundamentals about uh, this microscope things. So if you ask anybody, they will say that electron is a particle. We know electron, proton, neutron is a particle. So how they will behave like a wave? And at the same time, in 1923, de Broglie shows that every particle associated a wave nature it is. And this is, he has gave a relation that lambda is equal to h upon p, which is h is the Planck constant, p is the momentum, and lambda is your wavelength. So this wavelength can be associated. The mass of the electron is very light, small, which is fixed, but you can accelerate your electron and make it velocity very high, and therefore lambda will be smaller. Planck constant is again a constant. Therefore, if you imagine that you accelerate electron by applying a potential V, then you can relate and imagine that the potential you apply on electron, which energy is EV, is converted totally into their kinetic energy. This is assumption. Then EV is equal to half mv square. And you solve this, then you will finally end up an equation which is called lambda is equal to 150 by V in volt to the power half in angstrom. So, and if your speed is very high, then it will go for the relativistic correction, and then for lambda is equal to h upon 2 m0 ev1 plus ev by 2 m0 c squared to the power half. It means that if you see h is constant, m is constant, e is constant, only it depends on the voltage you applied. Therefore, you can apply a voltage, for example, 100 kilo electron volt, to see that electron, what is the wavelength of that electron. This is the relation of wavelength electron with applied voltage. If apply a voltage of 100 kilo electron volt, the fourth one, then the wavelength is now 0.37 angstrom, 0.037 angstrom, 0.037 nanometer. It means that wavelength is very, very small now. And if it is very, very small, it means that you can resolve much, much better. Okay. For example, you can, if you remember that wavelength for violet light is 4000 angstrom. But here it is 0.037 angstrom. So 10 to the power 6 times the smaller wavelength, and therefore it is many fold magnification is possible, and therefore resolution is many fold possible, and therefore people have made the microscope. So I will talk this slide little later, but I'll show you some pictures of the electron microscope and show that companies like Geol, or company like Hitachi, or company like FEI, or company like Philips, they made microscope based on this principle and use this thing for imaging of our things, our smaller things. So we are able to actually see smaller things, lattice fringes, diffraction will happen, and therefore you can calculate the lattice parameters. You can calculate the crystal structure of your material. You can calculate the by doing EDAX and EDAC yields. You can find out what are the impurities there, how the atom is arranged like that. So many things, many information you can gather from this microscope. Let us talk what are the problems. So what will happen when you apply, if anybody, our eye can see very nicely when photon will fall on us, light will fall on us. Since there is no mass, so therefore there is no problem. But when you send the electron beam has some mass, and therefore it will it will actually hit your system, and this mass will collide with your atoms or electrons present inside, and there many phenomena will happen. So there is a possibility of elastic scattering, there is a possibility of inelastic scattering, there is a possibility of generation of X-ray, there is a possibility of secondary electron generation, there is a possibility of characteristic electron generation, there is a possibility of back scatter electron generation, OJ electron generation, electron can absorb there in the sample, electron hole pair can form. So many things are happening. And if many things are happening, in that case, there's a many, you have to take care of all the things which is happening, and it's not an easy job. So suppose if you, for example, we can see in a air or in a vacuum, we don't need vacuum for normal seeing, like for our eye. But as you see that the interaction of electron with sample will happen, if electron will go and there is a air, the oxygen molecule, nitrogen molecule, there is a scattering because of that, there is a bombardment and there is a collision because of that, many problem will happen. Therefore, you need a vacuum inside, and therefore you have to develop a instrument which is inside the vacuum, and you can operate your electron microscope only inside the vacuum because of this problem. And these are the, you can see there is a many microscope has been developed by higher and higher voltage. As I told you that higher the voltage, the wavelength of electron will be lower, and therefore you are in position to measure the atoms or even smaller particles. I will show some data that how you can develop, you can see those details. For example, this is a microscope of 1.3 million electron volt by Hitachi. 1.3, this is the other one is the Philips CM300 with 300 kilo electron volt. So higher they apply very high voltage to make your electron beam wavelength smaller and smaller for higher resolution pictures. So these are the couple of images you can see. This is 1.2 million electron volt microscope. So they think that if you increase the potential, you apply the higher potential, you will resolve better and better. But this is not the case happen. So what will happen? This is again a microscope of CM12 of Philips company. So these I'm showing some of the picture which is very complicated, and I will discuss their working. So they looks like this, but how they work. So I will take a cross-section view of this microscope, and then I will talk more. So let us go to the this cross-section view. So this is the cross-section view of working of transmission electron microscope. So if you cut the microscope, then you will see inside like following. So what will happen? You have to have electron gun. This will produce electron, and a stream of electron is accelerated using anode, applying anode with high potential. And once it is aligned, you need a gun alignment coil which will allow the electron to flow in the right direction. Then there is an air gun lock. If something goes wrong, there is air lock will be there who cannot kill your this filament. Otherwise, filament is very costly. Then you use couple of lenses, electromagnetic lenses. I told you, electromagnetic lenses are known as condenser lenses, which condense the beam in a direction and make it parallel, and it will fall. So there is a two condenser lens. One condenser is not sufficient, so they put two condenser lenses, condenser number one and condenser lens number two, and then they will use this condenser and they have aperture. So how much electron beam you want to fall on your material, it's important because your material can burn if you apply a very high intensity of electron beam. So you have to have aperture to allow the small amount of electron beam on your sample. And then there is a sample block where you can fix your sample inside the vacuum. and your sample, therefore, you don't, it should be dry. You have to put with a different way of putting your samples. Not, you cannot put, there is a sample holder which will allow you to put the sample, and there is a grid which will allow your sample to be there, and then you fall your material on that. So these are the things which is required. Then you have objective lenses that will focus all the information of your material, and then you have a aperture, which is again diffraction aperture, diffraction lenses, and then projector lenses, which will project you in a bigger and bigger sizes. And finally, by using binocular, so what will happen? You will not see electron. Therefore, what you will do, you need a fluorescent screen, and that electron will be come, an image will form on the fluorescent screen, and then you can see by binocular, and you have digitally record those information, or you can record in a film. So this is the process by which a stream of electron beam is accelerated, it confined and focused using metal aperture and magnetic lenses, and then it interaction occurs inside the sample, radiation, it will fall on the sample, and that interaction and effects are detected and transformed into useful information. So these are the things which is the working of TEM, how TEM will work. But not only that, you have to have a vacuum system. Before, without that, this is the vacuum system. So this is the TEM column as a rectangle, and there's a many pumps are there. They will evacuate it first to a TEM column, otherwise you cannot on the beam. And when you evacuated it, so there is a vacuum technology very much involved in that. So vacuum technology will, there's many pumps like diffusion pump, ion pump, mechanical pump. These are all involved to make this TEM column evacuated. And then finally you use this technique to make make your sample, you take the useful information in images, and from there you can take the useful information. It will in one way it is very similar like the microscope which we use. If you two compare, then normal microscope you use lamp, but here you use electron beam. The other one you use a glass lens, but here you use electromagnetic lenses. Here you use sample, here you can use dry samples. The things it should be in vacuum, because then you have objective lenses. This is glass lens, here electromagnetic lens, then projector, and all these things are similar. But because of I told you the interaction with the electron, with the air and all, we have to do everything in vacuum, and then therefore the many problems will happen due to that. So these are the things which is important. If I compare about light microscope and electron microscope with different things, we can see here. There's many parameters. For example, wavelength, if I talk, it is 4,000 to 8,000 nanometer for visible light, but for electron, it is 0.037 angstrom for 100 kilo electron volt. Medium should be in light microscope, it should be air, but in electron microscope, it should be vacuum. Lenses, here use glass lenses, but in electron microscope, it is used electromagnetic lenses. Observation you can do here direct by your eye, but you cannot do it by eye, and you do it with fluorescent screen, as I discussed. Contrast is developed because of absorption, reflection, and phase changes. However, contrast is developed in electron microscope using phase changes, scattering, and diffraction. Resolving power is 0.2 micrometer for visible, but here 0.2 even angstrom in case of electron microscope. Focusing is possible mechanically, and in electron microscope, it is totally electronically dependent. So these are the parameters which is very important, and you can compare with light microscope and electron microscope. Then one thing is important is that how you can generate the electron beam. So for that you need filament. So there is a three kind of filament. One filament is tungsten, second is LAB6, and third is field emission gun. So these three guns are there, three filaments are there, and there's a cost involved in that, the quality involved in that. If I see that the different tungsten, LAB6, and field emission gun, if I compare about their beam current, their normalized brightness, lifetime, normalized price, temperature required vacuum. So if I compare, I can see that field emission gun is the best one, but the price is very high. But if you have a poor guy, if you have less money, then you can go for tungsten. But the problem is that the brightness is very less. with the tungsten, and therefore you cannot, resolution is not very good, and sometimes you cannot do the good quality microscope. So this is the thing, and those who are have medium size price, then they will take LAV6. So these three type of guns are possible to generate electron beam. So when you go to buy a microscope, you have to keep this in mind. Depending on your money, depending on your requirement, you can take any one of them or two of them or something like that, where you can buy this gun, which is very important. Based on that, the quality of the microscopy, the price also involved, and many things will increase. So this is the thing which I want to discuss. These are the lenses. Now come to the sample. So you have to prepare a sample. As you know, this is your sample should be very thin, otherwise electron will not transmit, because this name of this microscope is transmission electron microscope. It means that electron beam will transmit through it, and transmission is not possible because of the fact that if your sample is very thick. So what will happen if you have to make very thin sample, and therefore you use a grid. This is the sample holder, and the small arrow, it is written here. This is the grid where you put your sample. So if you zoom in the grid, it will looks like this. So this is the TEM grid, and it is coated with the polymer which is transparent to electron beam. So what will happen if you put some small this a small it's a polymer, and therefore you put some small amount of your sample, and then you can zoom it, because it will zoom 10,000, 20,000, 50,000, 100,000 times more. So even very small quantity will looks like very big. So your hair will look like very big tree or something like that. So therefore it is very important to put very small sample, and then diffraction will happen, and then you do. So you put your sample here, and then you fix it in this rod here, and this rod will go inside in the TM, and then you can use your microscopy. So this TEM grid is of 3 millimeter diameter, and it has typically 100 to 500 nanometer or less, thin, very thin things. And a pharma coating will be done on this to so that it will stick, the sample will stick on that, and therefore this is called a grid, where you have a copper, made of copper. So it can be of copper, gold, or many materials where it is made up of. So this is very important. If you zoom, for example, this is the copper grid. If you zoom inside the microscope, so it will look like this. If you zoom further, it will look like this. If you zoom further, it will look like this. You see? So 200 nanometer resolution. So it's very, this line is around 200 nanometers. So it's a very resolved. So first it is like, looks like this. Very first it is look like this. Inside the microscope, when it has resolved very less, then you resolve more, it looks like this. This is a copper grid, and farm are coated, and there is this opaque, there's this samples which is like dirt like this, which is a sample, and if you zoom it, it is nanoparticle. So you see, so nice nanoparticle is will be there. So in this way, you can really do very good quality imaging. As I told you, you can also do some very nice, let me show something if I have. Atom resolution, yeah. So you see here, I will show you here. This image is taken by us, and we published one paper. Here you see so nicely arranged silicon dioxide atom there on graphene. So you can see the atoms. You can see very nice atom arrangement. So this is kind of micro. You see here the nice atom arrangement, where hexagons, and it is not in hexagon, crystalline form or non-crystalline form. So this capability you have, you can see direct atom of silicon dioxide or any carbon or any hexagonal carbon like this. So what I can see that here, this we have published a paper, direct imaging of two-dimensional silica, glass, and graphene. So we are able to first time imagine the glass and graphene atom wise. So you can really, it is big thing that we are able to resolve. It is published in 10. So I'm not discussing this crystallography part, because this is tough, and it is not possible to explain all this thing in a very short time. But what is important is that we are able to do some imaging. So this transmission electron microscope is a multi-purpose machine. which can, what are the things it can do? It can do lattice parameter calculation. You can do that. You can do high resolution TM by seeing that. You can do the microstructure and defect study. You can do that. You can do chemistry using EDAX and IS measurement. You can do in situ cooling, heating behavior. So this is all you are possible through your transmission electron microscope. I have shown you some pictures where it is possible to see the atoms. So even you can see the atoms through this. So these are many things you can do using this microscope, and therefore it is very much needed for any kind of high quality research. If you are doing like energy or supercapacitor or solar cell or sensor or any metal based research or whatever. So if you want to see, or any biological things like smaller virus, bacteria, if you want to see the coronavirus or things like that, then you need these kind of things. So therefore you have to do, if your material are different, you can do diffraction many times and you can find the details. So there is a many ways to do that. However, I will finish it here saying that you can do diffraction, crystal structure information, you can do high resolution, you can see atoms, and all this thing is possible using transmission electron microscopy, and therefore it is a very versatile tool for doing high quality research. Thank you very much.
A hearty good afternoon and cordial welcome to the August gathering present here in online mode. I, Kazil,
And I, Gunveer.
welcome you all to this
Kazil,
valedictory session of 5-day international workshop on technological advancement in renewable
Malik.
energy, current scenario,
Malik,
future perspective and
please
challenges
ask Kazil to stop.
organized by Amity School of Life Sciences.
Sir, thanks a lot for
Yeah.
your very exhaustive lecture.
Mhm.
And we had always wanted to have this workshop in the offline mode, but due to certain constraints, you could not have it because you are from the academic field, we are from there. To keep the attention of the audience in the online mode is a bit difficult, and the real outcomes are they get missed up. But I'm very hopeful that the next program that we will be planning, and I definitely want whatever I have read about you, whatever Abhishek has conveyed to me, we definitely want that our students get benefited by your vast experience, and they get a live session of interacting with you. And I offer my gratitude and thanks to you, sir, for sparing your valuable time for this workshop. Thank you, sir.
Thank you.
Thank you, sir. Thank you.
Thank you very much, sir.
So now I am leaving the meeting.
Yeah, sir. Please. Thanks a lot.
We'll be starting our valedictory session soon. Our guest of honor will be just joining just for a minute.
Yeah. Malik, have you given a message to Professor Poddar?
Yes, he has sent me a message. I am joining in a minute.
Oh, that's good. Please continue to look at and the attendees. Sometimes he may be there, and we have to provide him the access of microphone and camera.
Yes,
So
yes,
you should be alert over there.
yes. ওকে বলো সন্দীপ পোদ্দারকে বস বানাতে। আচ্ছা, করে দিয়েছে। ওয়েলকাম, ডক্টর পোদ্দার।
Good
Thank
afternoon.
you.
How are you?
Fine, sir.
And nice to see you after I think 1.5 years or 2 years it must be.
How are you,
Right,
Dr.
right.
Kuldeep?
Yeah, I'm fine, sir. I'm fine.
And Dr. Molli?
Yes, yes, sir. Fine, sir.
Thank you.
Sir, Kuldeep sir, can we start the session?
Yeah, definitely. Our
Okay.
guest of honor has arrived, so we can start
Yes.
now. Yeah.
A hearty good afternoon and cordial welcome to the August gathering present here in online mode. I, Kazan,
And I will be.
welcome you all to this very interesting session of 5-day international workshop on technological advancement, renewable energy, current scenario, future perspective and challenges, organized by MIT School of Life Sciences, Department of Environmental Science. It is a proud privilege and honor to have amongst us our esteemed guest of honor, Professor Dr. Sandeep Podar, Deputy Vice Chancellor, Research and Innovation, Lincoln University College, Malaysia, as the guest of honor. We would like to extend a warm and cordial welcome to the distinguished guest.
Hello, namaste, sir. We would also
We would
extend a
also
heartfelt welcome to
extend
all the
a
eminent dignitaries,
heartfelt welcome
participants,
to all
and
the
attendees.
eminent
For
dignitaries,
the past 2 days,
participants,
we
and
have
attendees.
witnessed fruitful
For past
deliberations
4 days,
by
we have
eminent
witnessed
speakers.
fruitful
The active
deliberations by eminent
participation of
speakers. The
research
active
and
participation of research enthusiasts and scholars from different countries affirm the relevance and meaningfulness of this international workshop. It has been rightly said that greatness is not happenstance. It arises from purposeful intentions, dedicated efforts, wise counsels, and skilled execution, and the ability to see obstacles as stepping stones.
It is my profound pleasure to introduce our guest of honor to the audience, Professor Dr. Sandeep Podar, Deputy Vice Chancellor, Research and Innovation, Lincoln University College, Malaysia. Dr. Sandeep Podar is the Deputy Vice Chancellor, Research and Innovation at Lincoln University College, Malaysia. He has also served as Senior Research Director and Executive Editor, Publications, and as Adjunct Faculty Honorary at Bharat Center, Canada. Dr. Podar graduated from University of Calcutta with honors in zoology and obtained postgraduate diploma in dietetics from All India Institute of Hygiene and Public Health and Master of Science in Zoology with specialization in biochemical genetics from Dayal Bagh Educational Institute with distinction. In addition to this, he also obtained Master of Business Administration (MBA) from Lincoln University College. He earned his PhD in zoology from Vivekanand Institute of Medical Sciences on cytotoxicity and pursued postdoctoral research in different projects on hemoglobinopathies and oral cancer mutation.
He is also instrumental in the establishment of molecular diagnostics laboratory NEON at present under Desan Hospitals, Kolkata, and setting up biotechnology laboratory at college in Hooghly, West Bengal. Under University of Bardhaman, he has published several research papers in reputed Scopus, Web of Science, and Dexter journals and books, filed more than 15 patents, organized international conferences, and also edited books in Malaysia, Australia, and India. He is an active member of different organizations, ISCA, ISNA, World Academy of Sciences, Mental Health Innovation Network, and also fellow member of World Researchers Association's Indian Academic Researchers Association.
I would now invite our guest of honor, Professor Dr. Sandeep Podar, for his address. Sir, please.
Thank you. And for a vivid discussion about me, Miss Kajal and Miss Dipstan.
Sir, please unmute.
Oh, sorry. Thank you. Now is audible?
Yes, sir. Yes.
So I must thanks Miss Kajol and Mr. Nikhil to give a heavy description about me, and also Mr. Gunveer to invite me, giving the stage to me, and Dr. Kuldeep for your kind invitation email, and Dr. Ritabrata for taking the initiative, of course, about the conference, and all the delegates here. I just want to share my slides and my view, what about my thinking, not your thinking, because you are the experts and you have joined this workshop for some knowledge sharing, and you have already got the information in last few days in your mind, and there is a different tracks you have discussed. So I just sharing my view, point of view about the renewable energy actually. I am sharing my screen first. My slide is okay, visible, full? Okay. So we are here on technological advancement in renewable energy, current scenario, future perspective, and challenges. When we are talking about this current scenario, that is the present where you are, we have to think what is the past as well. Then only we can plan about the future. And then we can do the SWOT analysis, that strength, weakness, and threat and opportunities that gives us the challenges. May I request to disable the waiting room, then everybody can join quickly. No need of waiting room in the participant. I can do. No, I cannot do. First, I have to do disable in a waiting room. Okay, sorry. And Amit University, Madhya Pradesh have taken the initiative to do this. So we are talking about the renewable energy and the current first, and then we have to think about future as well as challenges. So as I'm telling that we have to do the SWOT analysis for the challenges. So we will discuss this in a brief manner in this short description. So as all of us know that renewable energy is the energy derived from the natural sources that are replenished at a higher rate than they are consumed. So main source of energy in earth is sunlight, of course, because sun before earth is cooled down, it is a part of sun, and the sunlight is always giving the energy. Now it is cooled, and the sunlight is the major source of heat to earth. And then the remotest part where the sunlight is not reaching the northern pole or the southern pole of the world, there is total ice. So the energy is related to heat, and of course the mechanical energy is transformed to electrical energy. So these all different types of energy we are handling. Wind is a source of energy as well, where we use different types of mechanical equipments to transform this wind energy into electrical powers, different forms of energy. So it is the interchange of different types of energy in different forms. It is not that we are producing the energy. The energy is already there. It is a modified version. It is a breaking down of the chemical composition of a particle or a molecule. And during this molecule breaking, the covalent bond or the triple bond is breaking down. So the energy is released. And when the energy is joined, then it is become a molecule. So like that way, in our every cell of our human body is producing energy and consuming energy. So in the respiratory chain, ADP transform to ATP, gaining the energy, and ATP release the one phosphate bond. Breaking down that bond is releasing some energy that is causing us, giving the energy to us, to our body to move. If the ADP is not transformed to ATP, the energy is not stored, and ATP is not converted to ADP, the energy is not released. So if energy is not released, we cannot move. So we will die. That is the respiration, and that is the main theme of our life. So energy is just a mode what we cannot produce, but it should generate from one form to another. Now, as we know, we are talking about the renewable energy. So what is there? Of all energy is renewable, we can think. All the trees is naturally grown, and it can be cut down and it can make fire. Is it so? No. Our terms means we think that energy is derived from the natural sources, but they should be replenished at a higher rate than it is consumed. So there is solar energy, wind energy, geothermal energy, hydropower, ocean energy, and bioenergy. I just give example of few. The solar energy, that solar cooking is, you can see this is a farmers with a vision, and I have taken this pic with a website, from the website, that normally the solar cooking is going on, and all the villagers is using this type of system to cook their food because there is no other electricity, no other power is available. There is so much storm, there is so much what you call power cut. They cannot have electricity in their places, no air condition, no fan, etc. But they have to cook. But the sun is scorching sun. So we have to use that sunlight, and they are using it. And I just show you. This is the farmers with a vision in Kenya. In most of the Nigeria, South Africa, they are facing this type of problem. And because their sunlight is more and no water. And of course, there are different types of weather condition, environment. So they are cooking an advanced type of the solar cooking system also we can see in different places. But basic thing, they do from local wood and to distribute it to the villagers, and they are using it. So this is the sustainability of the solar power, and that is the viewpoint of our sustainability of this for the future. Now you see, now next is wind energy, solar energy. Solar energy, I have visited Cambodia few months ago, and I have seen the airport to the city, the new road have been constructed with this solar power light. There is no electricity. And if you know that if we want to use the electricity by power, then we have to pull the wire from one lamp post to another light. And that wire should be connected to the source. Now here no wire required because each lamp post is separate from each. And every lamp post have solar battery cells. So that solar is lighting, giving the energy to one lamp post, another one separate. So there is no connection need of wire. So wireless technology, there is the advancement of technology using, and that wireless technology can save many birds and many consume of the metal wires, and there are many things have been saved due to this new technology, use of solar power. Maybe we can tell that, oh, maybe battery is consuming or other things. Of course, there are drawbacks, but you can see the heading in the newspaper, in the Star. It is 70% green energy targeted before 2030. Because why 2030? 2030 is the year the United Nations have set a goal that they have 17 sustainable development goal to be achieved by year 2030. So the solar power individually it is done. Next, if we see the solar power as well in different places, this one is the news. I just show you. Okay. So you can check later on, no problem. As next is the wind power. This picture is Kanyakumari in our India, where I have traveled few years back before COVID. And beside the hospital, we have visited the hospital there in Kanyakumari area, village area. There is lots of air turbine. And in my life, first time I saw the air turbine, of course, I have to take photo with that. And always it is moving very slowly. We don't think that it is moving very fast. And that mechanical energy, the wind, that mechanical movement is transformed into turbine and electricity. And that electricity is the main source of electric in that region, whole area. There is no other source needed. There is no need of any solar, no need of any electricity, no need means the fuel for this production of electricity. So it depends upon the weather and the environment of that area, ecology of that area. If it is in a desert, maybe the wind turbine or the solar system. If it is in a cold place, there is always cloudy, Of course, there is wind turbine, not that solar turbine in solar system will work. And if it is hilly area, we cannot think that we cannot fix a big air turbine in hilly area because it may cause danger. So different places, according to the altitude and the place, we have to fix the renewable energy source. Next, the geothermal energy. It is another source from the earth crust, and in the earth, the different types like this hot water, spring of water, hot spring we can use, and we are using in different places in different country to means release the energy. You can see I have visited one volcano. The volcano is a living volcano, but not so high rate. You can see that steam is coming out from the hot water, and people is doing tourism across these means this volcano. They are taking the bath massage of the hot water in that, and of course they cooking the egg. You can see right side the blue basket. They keep the egg there, and within 10 minutes the egg is boiled, and we are taking there in the place. So these things, it is not easy to use a volcano energy because volcano anytime it is erupt more, maybe less, or maybe close down. So it is not so easy to use that power. But there are different sources of geothermal energy, and I just show you that how this geothermal energy is moving. You can see in Wikipedia, in different states, means different what you call country, like US, geothermal production, Indonesia, geothermal production, Philippines, Turkey. So the production of geothermal electricity is more and more. Every year it is increasing. Okay. So you can see different types of geothermal energy is there. Another one is the hydro energy. You can see this video. This video I have taken yesterday in Malaysia itself in a food court. The water is falling down, you can see, and how much forcefully it is falling down. The person put the bucket and the water flow so much high that it crossed the bucket as well, and it filled the bucket. So the person take 1-2 bucket, after that he cannot come back and no need of more water. So this source of high force of water is we can use to create the energy. It will move the turbine, and we are of course using this water what you call hydro fuel, and there are different. You can see the micro hydro power turbine. The market size increasing every year. There is target 2023, now 2028 will be this type of high growth of this hydropower. So you can see that how different companies involved, and they have the market and business with these water turbine sources. Okay. And also energy from seawater, the mixing of fresh seawater with the seawater also there. That is also a part of hydro technology. But as sustainability, of course, always it is not take part. There is always threat. And like in Malaysia itself, the hydropower in Sarawak, one of the state in Malaysia, it is unsustainable and unnecessary. Why? Because the environment is affected with this hydropower energy. It's creating problem in the local environment. So it is unsuitable there. and unnecessary. So after construction, it is we have start means Malaysia have started, but after that it found not sustainable due to the proper placement. So of course there is a sustainability question mark. And as I am talking about the ocean, from the water of ocean, you can see it is US. The sea wave is giving the energy, and another one is here, just that I already shown you, that energy from sea water. And if we think that the renewable energy and the natural sources, the energy from natural sources means we cut the tree and it will make the energy, it is not right. Sometimes we thought that, okay, we are traveling by train, so it will save energy. But we have to see that where the train is running, which energy. Of course, it is electric energy. Now that electric energy is produced from where? Where is the source? Now, suppose here in Malaysia, I have seen, means they have also seen that the local metro means local train is a automatic train is running in the city. So that one is by electricity, and that electricity is generated from petroleum. So the petrol is consumed and electricity is converted, and then electricity means the train is running. So we have to think the source of the energy. And of course, there is another source. Somebody a note. Okay. So there is a source of biofuel that is the latest development. And biofuel, it is not latest, it is old age. Old age we have used. I have seen in my childhood the cow dung is used for the fuel. And there is now cow industry is different. And of course, even different, we can use the biogas as we using before in previously. It is stored and it is forming different types of, it is giving the what you call the source for cooking, source for light in the house, of course. So there is no need of other thing if there is cow dung and other thing. Can again somebody make a note? Mr. Pritish Soni. Okay. So, and of course, you can see the Zimbabwe and other country still using in the cow dung electricity and this leaf changes for the villagers. So many places in many countries, even in India and abroad, they are still using the cow dung production, cow dung as a source of renewable energy. And of course, when we are talking about biogas and bioenergy, not only these cow dung only, the different sources of vegetables and other things also used. And in Malaysia as well, I just want to show you that one of our Bengali person. And just 1 minute. Biofuel is produced and they have collecting different fuels, means the waste oil from the kitchen of the hotels, and that hotel oils is transformed to biodiesel. So the cooking oil is transformed to biodiesel, and that one is used for the moving of the car, the future energy. So biojet is flying in different countries, in Abu Dhabi, in of course the fat means other places in Bhutan, everywhere they are using different sources to use these bio fuel to cause the energy, release the energy. Now, as we are talking about sustainability, we are talking about with the United Nations Sustainable Development Goal. Number 1 is no poverty, number 2, zero hunger, number 3, good health, and number 4, quality education. Like that, we are talking, and number 17 is partnership for the goal. All the goals are interlinked with each other, and we are all working together with each other to achieve this goal by the year 2030. And of course, if we think about life below water is separate, life above water is different, it is not that. All is interlinked. If the source from the seawater is high, a huge source of ocean, that energy can be used for the life of the land. And we have to use the land sources as well to release the energy from the sea. So, without wasting much time, I must tell we must network and collaboration. And today, of course, another important day, World Water Day. And we are also this year, the theme is the water for peace. So we are making networking collaboration. And of course, thank you all again to Amity University, to Gwalior, to organize this event. And we are from Lincoln University College in Malaysia. It is consecutively for 4 years, it is 5-star rank. And last 2 years, it is 6-star rank university, top private university in Malaysia. And in quality education delivery, Times ranking below 32. And we have more than 170 programs and world ranking, others QS ranking also there. So I invite all of you to visit Malaysia whenever you free time, and feel free. Thank you once again. Thank you to Dr. Ritarbroto and Dr. Professor Kuldeep. Thank you to all participants.
Thank you, sir, for enlightening the attendees and participants with such useful information. Thank you once again. I would now like to invite Professor Dr. Kuldeep Dwivedi, Head, Amity School of Life Sciences, Department of EVS, Deputy Dean Academics, and Governor of this 5-day international workshop for concluding remarks. Sir, please.
Thank you, Kajal, and thank you, Guneet. It has been a very fulfilling 5 days to have come across such learned people and the knowledge that they shared through their lectures in the technical sessions. Professor Sandeep Poddar sir, the other dignitaries present over here, the participants, and my dear students. When we plan to have this type of workshop, particularly in a topic where people are still in their very primary stage of information, particularly the student community, the research scholars, and it's a sector which actually defines the developmental perspectives of any community and any country, because energy is one of the most important aspect as far as what Poddar sir said, attaining the 17 sustainable goals also, because it is intricately related not only to the economic well-being, the robustness of the economy, it is also related, very intricately related to the concept of global warming and to the sustainable development, because the types of sources that we are having as far as generating the energy to fulfill our ever-increasing needs is mostly sustained by sources which are polluting the environment. So we need to look at avenues which are non-conventional, which are non-polluting, which do not add up to the carbon and other polluting gases to the atmosphere. So looking into the different sources that the different people, the scientists, the researchers are trying to explore as well as to fulfill our energy needs, which is increasing day by day, we need to, and definitely we need to look at some of the non-conventional sources of energy. One of those has been the solar energy, and India is at the forefront, leading the world as far as in the form of solar alliance and establishing a network of grids for generation of solar energy. And the emphasis and the target of this present government is that we fulfill at least up to 20 to 30% of our energy needs by harnessing solar energy, which is so abundantly being given to us by nature. The other that Sandeep Poddar has very well outlined the different sources, the geothermal energy, the hydro energy, and we need to look beyond that. And the lectures that have been given by eminent speakers, which we were able to invite, and they graciously accepted our invitation. It ranged from, I will just like to go through the people who had come and enlightened us about the different aspects of energy. When we planned this workshop, we made it a point that not only the researchers and the people who are directly related to the production or the development of technologies as far as non-renewable sources of energy are concerned should be there. We also made it a point that we will invite people who are directly into the installation, the market, because the market becomes a very important aspect as far as energy production and dissemination is concerned. So as a guest of honor, we had Deepak Khare. He is the head of projects Blue Pine Energy, Gurugram, Haryana, and is presently heading the projects particularly related to renewable energies in India. It's an MNC which is into the harnessing of renewable energies. Then he was very well supported by our chief guest, Dr. Nitin Labsetwar, who is the chief scientist and head energy and resource management division, CSIR, NERI. And he highlighted the issues like clean energy, sustainable challenge and opportunity. And most importantly, what he discussed was the 18 challenges as far as the world solar map is concerned, the sale of the dissemination, the channelizing of the trapped solar energy and its utilization, particularly in generation, efficient utilization. And then he also emphasized on the new materials that need to be developed as far as to prolong the shelf life of the batteries, particularly the utilization of nano materials. And then as part of our mandate that we tried to address was that we need people, experts who have worked in real sense among the different communities as far as the sustainability and energy was concerned. And luckily we got Ispita Nandi Banerjee, who is a communication and gendering lead, United States Energy Association, Energy Utility Partnership Program, and US Department of State Women Energy Leaders Program. And in her lecture, she emphasized on the energy efficient systems of India, particularly in the developing or the third world countries, particularly Bhutan, Rwanda, and other such countries. And she focused her work within live examples of how the small efforts by a small community can lead to sustainable development, self-reliance as far as energy was concerned, particularly when she showed us the video of a Tanzanian village where the women have played a very enterprising role as far as the renewable energy and the making that community self-reliant in terms of their needs for energy was concerned. And this workshop was spread over for 5 days. And in every day we had a technical session of 3 hours. And the lectures covered from different we got speakers from different parts of the globe. Just for example, I would like to state Dr. Mi Tian. She is a senior lecturer in low carbon engineering, University of Exeter, UK, member of the Global Sustainability Initiative. And she, in her lecture, emphasized on the role of hydrogen, particularly the storage of hydrogen and the technologies that are being undertaken, which are being developed for harnessing hydrogen as a source of energy. And then Rishi Sharma, he principal scientist, semiconductor, sensors, and microsystem group. He deliberated on the development of nanomaterials and their application as far as energy production and storage was concerned. Then we had a very veteran person who in the field of energy, particularly solar energy. Santipada Gon Chaudhary, who is presently working as a visiting professor in Sipur, and also was the chairman of the Energy Expert Committee, Government of India. And he deliberated extensively on the renewable energy status of India, the thrust areas, that is the solar, wind, bio, and hydropower energy. And he laid down a whole scenario in front of us to explain the global scenario of technological advancement about various aspects and developmental initiatives that are taken up by the different governments and different agencies as far as the development of non-renewable sources of energy is concerned. So in the next session, we had Professor Balchandran from the Department of Environmental Sciences, Vishwabharati University, Santiniketan. We also had Dhiren Chaudhary, Head Center for Renewable Energy, Purvanchal University, Jaunpur. And he, in his lecture, was emphasized and deliberated on the types of nanocomposites, semi-transparent solar cell devices, perovskite materials, solar cell synthesized, and their characterization. And this characterization was also extensively discussed today by Achal Srivastava, the professor at BHU, particularly of the nanomaterials, which have the potential for enhancing the shelf life of the batteries and the photovoltaic devices. Then we had Abhishek Kumar Mishra from the UPS Dehradun. He spoke about the carbon capture, utilization, and storage of different types of catalyst development and the different challenges that are involved in it. We also had Dr. Srinivas Natarajan from the Industrial Hygiene Coordinator, Tefcan Construction and Installation, Ras Laffan Industrial City, Al Khor, Qatar. And he also talked about the renewable energy sources, with the current trends and plans, particularly in the Gulf countries, how they are undertaking and what initiatives they are taking as far as making that part of the world self-reliant or to have more percentage and more contribution by the renewable sources of energy. And today then we also have from the industry, we had Dr. Naren Tomar, who is the business lead, Sungrow Power Limited, Gurgaon. And he discussed extensively on the projects that are being undertaken, the challenges they are facing, the cost benefit analysis of installing small, large scale, and micro level solar plants and solar grids. So we made a very earnest effort on our part to have an array of speakers and experts from different aspects which are related to the development of the renewable energy sources in India and different parts of the world. And I sincerely hope that the participants might have benefited from it, and that this might have also given, like the people from the industry, they also emphasize on Deepak Khare, he emphasized that in the next 2-3 years, they need around 50,000 professionals who are trained manpower as far as the utilization, installation, distribution of the different renewable energy sources are concerned. So that is a very interesting fact, because we need to increase the employment, and harnessing different sources of renewable energy will definitely make us more sustainable. It will definitely have an impact as far as our fight against climate change is concerned, and it will have a very sound effect as far as the economy of the country are concerned, because they affect at the micro level. And that was also emphasized by Sandeep Poddar sir also, that how villagers in a particular part of world, that is Cambodia, they could sustain themselves, they could have the amount of energy through processing of different agricultural waste and other waste. So with these words, I hope and that this workshop must have provided a very good, insightful impact on the participants and the attendees. And this must lay the platform so that because it is the students and the research scholars which will be taking up different types of research as far as utilization of different sources of renewable energy and different materials which can be utilized as far as their storage, increasing the shelf life and the sustainability of the energy scenario the world over is concerned. And with this, I thank each and every one of you. Thank you.
Thank you, sir. We are extremely delighted to know about the information related to the successful conduct of this international workshop. I would now like to hand over the session to Dr. Abhishek Kumar Bharadwaj, Assistant Professor, EVS Department. Sir, please.
Thank you for the opportunity here. So I request to the participants to give your feedback regarding our workshop. So anyone please? Yeah. So Surjit Karmakar ji. So I request you.
The IT personnel to provide both of them access to microphone and camera. Malik, please ask the IT person.
There's already given.
Okay, okay. So you can put on your, yeah.
Good afternoon, everyone. I'm Yanashri from
Can you speak a little bit louder?
Tamil Nadu, with a background of environmental. Yes, sir, definitely. Good afternoon, everyone. I'm Yanashri from Tamil Nadu with a background of environmental science. Currently, I'm a student in Bharathasan University, Tiruchirappalli. This international workshop on technical advancements in renewable energy, hosted by the Department of Environmental Science, Amity University, provided an important platform to discuss the renewable energy scenario, the future potentials and challenges. It was very useful. The platform served exchangeable ideas and exposures to innovative solutions. This workshop emphasizes on technical advancements, highlighted the crucial role of innovation in advancements of sustainable energy sources. Among all, one lecture given by Dr. Nitin sir discussed about the cleaner energy and sustainable challenges and opportunities and efficient utilization of nano approach biomass. Conversion was very helpful to me. Lastly, I would like to thank this workshop that facilitated a meaningful discussion and a collaborative efforts towards the greener and more sustainable future. Thank you.
Thank you.
Thank you for your feedback. Now I call to the Surjit Karmakar ji, please.
Mr. Surjit.
Dr. Surjit Karmakar. So is there anything? Surjit Karmakar ji, unmute yourself, please.
He's asking for access. Dr. Malik?
Sir,
has
he is
written on
already the
chat box.
co-host.
I think he's not able to put on his mic and the microphone.
Okay, I'm requesting.
Yeah.
Surjit Karmakar ji, you are already a co-host. Please try to unmute yourself. You have logged in from two devices, I think.
That must be the reason.
Surjit Karmakar ji.
Surajit Kamakar, if you are logging from two devices, please join from one.
I have also like to. Yes. Already appearing here as a co-host.
Sir, I remove all the rights. Now everybody have a right to speak and open the video.
No, don't do that. I think we can continue.
Anyone? Yeah, so okay. So the wind up.
Okay, so
Okay. So thank you for your sharing your experience. We assure that we would try to provide these kind of opportunity further to all of you in future. So thank you once again for your wonderful sharing your experience.
Am I audible, sir?
Thank you. Yeah, you audible. Yeah.
Okay.
Now you audible.
Good afternoon, everyone. I am Surjit Karmakar from Kolkata, West Bengal. Hello.
yes.
Yes. Okay, sir. West Bengal with a background in environmental science and participants of IWTA RE 2024. Currently working as a scholar at CSIR NED, Kolkata Journal Center. The International Workshop on Technological Advancements in Renewable Energy, hosted by Department of Environmental Science, Amity University, provided an extensive overview of renewable energy's current status, future potentials, and challenges. It served a platform for me to exchange ideas and explore innovative solutions. The workshop's emphasis on technological advancement highlighted the crucial role of innovation in propelling the shift towards sustainable energy sources. Among all, one lecture given by Professor Dr. S. Balachandran from Viswabharati highlighted the socio-economic challenges and health issues associated with traditional energy fuels. And shifting from traditional to biogas fuel was very helpful for me, as I also have worked on biogas fuel. Overall, these workshops facilitate meaningful discussions and collaborative efforts towards a greener and more sustainable future. Thank you.
So thank you, Suranjit Karmakarji, for your kind words about the workshop. So thank you all. So I think now over to the anchor. Please handle this moment.
Thank you, sir. I would now request Dr. Ritabrata Malik, Associate Professor, Environmental Science, Organizing Secretary of 5-Day International Workshop on Technological Advancements in Renewable Energy, Current Scenario, Future Perspective, and Challenges to propose vote of thanks.
Thank you, Nikhil. It has been a great 5 days of exhaustive sessions, starting from the inaugural session till the valedictory session. We have seen the presentation of different dignitaries, renowned dignitaries throughout the world from different countries on various topics, right? Starting from carbon emission, from the carbon storage, from hydrogen, from the different type of energy, present scenario, future perspectives, technological aspects, and different scenarios. Starting from the inaugural session, I like to thank the Deepak Khare, the head of projects renewable business from the independent power producer. The Gurugram, he has been an enthusiastic speaker that from the inaugural session. Then we have Dr. Nitin, he's the chief scientist and head energy of resources. CSIR NIRI, he has given us exhaustive lecture on the based on different types of energy related projects. Then we have Miss Ipshita Nandi Banerjee. She is from Communication and Energy Engineering Lead, United States Energy Association, USEA. He has given us different perspective of utility partnership program. After the inaugural session, we have the first technical session, which was being chaired by Professor Vinay Dwivedi, and so I will be thanking him also for chairing the session. Then we have the invited lecture of Dr. Mi Tian from senior lecturer in low carbon. She was from University of Exeter, United Kingdom. Then I would like to thank the next invited lecturer, Dr. Rishi Sharma. He was from Principal Scientist Semiconductor Sensor from CSIR. And after the first day of these sessions, we had the second day on 19 March. We have the chairman of Dr. Brajen Shukla. and the invited lecture of Dr. Abhay Kumar Pandey. He is one professor from Department of Biochemistry, University of Allahabad. After that, I would like to thank the invited lecture given by Professor Santipada Ganchodhary. He is one Chairman Energy Expert Committee, Government of India, who has given exhaustive feature and present scenario of Government of India's different projects based on the renewable energy sector. On day 3, we had the privilege of having in our lecture, the invited lecture of Professor S. Balachandran. The session was chaired by Professor Dr. Vikas Srivastava from MIT Institute of Biotechnology. Professor Balachandran was Associate Professor, Department of Environmental Science, Vishwavarti University. He has highlighted many aspects regarding the present scenario of energy and energy conservation. Then we have the invited lecture by Dr. Dhiren Chaudhary. I would like to thank Dr. Chaudhary for giving his valuable time. He is presently the head of Center of Renewable Energy, VBS Purbanchal University. And the third invited speaker was Dr. Abhishek Kumar Mishra from Department of Physics, UPS. He has given his views on different energy aspects, and we also like to thank him. On the day 4, we are having 3 lectures again, and that was being chaired by Dr. Professor Raghavendra Mishra Saxena. An invited lecture was from Dr. Srinivasan Natarajan. He is the Industrial Hygiene Coordinator from Al Khor, Qatar. He has given his views on health safety. And then we have the invited lecture by Professor Neelam Pathak. She was the head of Department Biochemistry, Ram Manohar Lohia Awadh University, Faridabad. And then the third invited lecture was given by Dr. Harin Tomar, Business Head, Sangro Power Limited, Gurgaon. After this, we had the privilege of having with us Professor Achal Srivastava, Department of Physics, Varanasi University, Varanasi. He has given the 5th technical session lecture. Then we had with us, I would like to thank Professor Sandeep Poddar being the guest of honor in this session, a valedictory session. In the mean, also I'd like to thank Professor Kuldeep Dwivedi as the convener and the head of the department of this Environmental Science Department, Professor Sapnil Rai, Dr. Abhishek Bharadwaj, Dr. Nidhi Shukla, Dr. Deep Chakrabarti for supporting. I would like to thank Dr. Jeva Siddiqui and our team for supporting as volunteering the session of inaugural and valedictory session. I'd like to thank our Honorable Pro Chancellor, Sir, Lieutenant General V.K. Sharma from MIT University, officiating Vice Chancellor, Professor Anil Bashishi, and Pro Vice Chancellor Research, Dr. MP, Professor MP Kaushik. And overall, I would like to thank every participant participating in this event for 5 days. And they have been participating from different parts, so not only from India, from outside also. Research scholars, students, and faculties who have from different sectors, from energy sector, from academic sector, have participated enthusiastically and asked different interactions were done, questions were being asked, and several issues were being developed. We would like to have this kind of conference and workshop in future also, where we can have more participants and in a fruitful way. So I'd like to thank from the Department of Environmental Science for this international workshop, to all the dignitaries present here and all the faculties and all the students. Thank you very much.
Thank you, sir. With this, we have reached the culmination of 5-day international workshop on technological advancements in renewable energy, current scenario, future perspective, and challenges organized by Amity School of Life Sciences, Department of Environmental Science. We would like to thank all the dignitaries, attendees, and participants for their presence. Thank you, everyone, and have a great day ahead.
Thank you, Professor Poddar sir. Thank you very much for your valuable time, and to have you with us is really very encouraging for us. And I thank you because in spite of such a busy schedule, you have been able to be part of us. Thank you again, sir. Thank you.
Thank you. Thank you.
Right, you can close.